Welcome to our presentation. Introducing.
Assalamualaikum. Welcome to our presentation for final year project subject. This group consists of 3 members.
Hi, my name is Nurul Qurratu'aini Binti Mohamad Talib. So now I will explain about the problem statement for our project, which is IOT based food quality monitoring system. During storage and transit of the food to the place to be delivered, food tends to spoil due to factors such as temperature, humidity, and alcohol presence in the air. Hence, the catering owners need to monitor the ideal surrounding of the food manually in order to prevent it from spoiling. The idea of this project was then created as part of the aim to avoid food spoilage caused by the surrounding condition. Thus, our objectives are: first, to develop a prototype for IoT-based food quality monitoring system by using the Arduino Uno microcontroller, and the second one, to design a schematic diagram of the IoT-based food quality monitoring system by using the Project 8.9 and Arduino IDE.
Hello, I'm Dalila Binti Azazlan, and I'm going to continue this presentation by explaining to you about the overview of our project. This project proposes IoT system of food surveillance in order to prevent foods from being contaminated and spoiling quickly during the transit. This project also allows us to sense the surrounding state of the food and collect data by using components such as THT11 as a humidity and temperature sensor and MQ3 as a gas sensor. When the data is collected, it will then be displayed on the LCD in terms of humidity, temperature, as well as reading of alcohol presence in the air. The data will then alert the owner whether the food is in an ideal surrounding state to be kept or not by turning on either green or red LED.
Block diagram of our project. This block diagram will list out all the components used in this project as it shows the microcontroller inputs and outputs used in IoT-based food quality monitoring system. As can be seen, the inputs of this project are components such as DHT11 and MQ3 sensor. Meanwhile, the output used are components such as LED and LCD. The microcontroller used in this project is Arduino Uno, as the programming for it is easier compared to other microcontrollers. With the help of ESP8266 Wi-Fi module, it helps send collected data through the web server. The web server used is ThinkSpeak server for online data visualization. Next is a software design. First, we have a circuit diagram. This is the circuit diagram of our project. This circuit diagram uses simple images of components to show the interconnection of the circuit. Schematic diagram for our project. This schematic diagram was constructed by using Project Professional 8.9 software. This schematic diagram is also used to simulate our prototype to know if the codings are working fine or not. Moving on to the flowchart of this project. Based on the flowchart, the process of the project can be understandable. First, when a particular food is tested, 2 sensors which are DHT11 and MQ3 will detect the temperature, humidity and also the concentration of ethanol gas present in the air. If the concentration of ethanol gas is high, the red LED will turn on, and vice versa. At the same time, the Wi-Fi module ESP8268 will send the data to the ThinkSpeak server.
So, this is our simulation result using Proteus Professional 8.9.
As can be observed in the simulation result, the green LED is on because the concentration reading of ethanol gas is 0.
So, this is the full view of our prototype. So now, we will show how our project works.
Red LED is on because the concentration reading of internal gas is high, which is exceed 300 ppm.
These are the data collected from the ThinkSpeak server. This data was obtained from the food tasted after it was left in the living room for 24 hours. The reading for concentration of internal gas and humidity increased. However, the reading for temperature of the surrounding remained the same.
Hello, my name is Nurul. I'm Nasir.
The chosen food for this experiment is nasi hujan panas along with ayam masak merah and cucumber pickles as a side dish. As the food is still freshly cooked, the food was monitored in the prototype and the result of the food was in a good condition and the green LED was turned on. Then, the food was left in the living room for 1 day. After 1 day, the visual of the food was confusing as it is still looking good to eat. The food then was monitored again in the prototype and the result was unexpected. The humidity and the gas presence in the prototype were increased and the red LED was turned on, indicating that the food need to be thrown away.
So now I will continue by sharing a little bit about our troubleshooting process. Upon completion of the process of assembling all the components on the street board and prototype, there were some problems found when we were about to start the food monitoring process. To identify, we troubleshoot our project hardware. Among the problems encountered during the troubleshooting process is that the LCD does not show any output, or it still shows the output but it is a bit blurry. Therefore, we identify that this problem comes from the setting of the potential meter. This component is adjustable, and this component function is to adjust the bias level and text contrast value of the LCD. Hence, if we set the potentiometer to the correct value, the LCD can show any output clearly and vividly. Other than that, we also found that our LCD didn't working, and then we identified that this problem occurred due to a short circuit that happened between the ground voltage supply and also the components on the street board. This is because each line on the street board is connected. So, if there are any components placed on the same line with any voltage supply or ground, all of them will be on the same line and cause a short circuit. Thus, to solve this problem, we scrap some lines between the legs of the components with the supply voltage and the ground in order to disconnect the street board connection.
In conclusion, IoT-based food quality monitoring system was successfully worked as it can monitor and detect the food, either they can still be eaten or not, by using DHT11 sensor and MP3 sensor. With that, the aim of this project, which is to avoid food spoilage caused by the surrounding condition, was achieved. Next, the prototype for this project was perfectly developed using the Arduino Uno microcontroller. Lastly, the schematic diagram of this project was designed by using the Proteus 8.9 software and run by interfacing it with Arduino IDE coding.
This project is a success with all the inputs and outputs are working according to the expected results. However, there are some recommendations that can improve this project. Firstly, a GSM module can be added into this project, communicate with the caterers through telephone only. With the addition of this GSM module, this project can be more friendly user and also convenient. Then, the recent LCD display can be switched to a big one. With this step, the data reading can be displayed more informative and interesting. Other than that, batch level sensor can also be added into this project. With this addition, this IoT-based food quality monitoring system can be used not only for foods but also in drink, as it can sense the acidity in liquids.
That's all from
Us.